So much for that. Arterial, now we'll talk about this too later, y'all. We'll talk about the arterial oxygen content must be about 20.3 mLs per 100 mLs of blood. That we'll talk about also later on. When we get to respiration, we'll talk about how this is figured. In other words, I will tell you that 1 gram, okay girls, this is why, girls and guys, but mainly the girls right here, this is why your hemoglobin count needs to be up. 1 gram of hemoglobin carries a certain amount of oxygen. And 1 gram of hemoglobin, you need so many grams per 100 mLs of blood. And if your grams of hemoglobin is low, and if this number gets below that, you will feel anemic. If it gets down way below that, when we get to respiration, we'll get into this. And I'll tell you how that works. 1 gram of hemoglobin carries so many mLs of oxygen. Therefore, you need so many grams of hemoglobin, which we're going to do that later. I'm not going to get into that now. In fact, I've kind of forgot some of those numbers. I have to review them, and you would too. You know, some of those numbers you kind of got to review. And so I'll have to review the numbers on that. But that's why your hemoglobin level, that's why your hematocrit. Your hematocrit should be pretty good. And we'll get into that too. We're going to get into that when we get into blood. Your hematocrit is percent blood cell volume, red blood cell. That's hematocrit. And we'll talk about the average hematocrit for males and females. We'll do that. We're going to do that in lab. We're going to do some hematocrit in lab. All right, we'll do a hematocrit on 1 or 2 of you. Anybody in here ever been anemic? Anybody anemic right now? And nobody's anemic right now, are they? If I could tell you in our lab, I can tell you if you're anemic. I can do a hematocrit. I have a hematocrit centrifuge. All I have to do is draw a little tube of blood, a little tube of blood, pipette of blood, and I'll do mine. I'll show you my hematocrit. It works. And for a woman, it's got to be the average hematocrit is about 42. Males, the average hematocrit is about 45. And so if I do a hematocrit on you, and your hematocrit shows up on there as 35 or 20, then I say, are you anemic? You might be a little anemic, okay? All right, we'll do that later on. And we'll also do oxygen content later. That's pretty good. Red blood cell count, about 5.4 million red blood cell count. All right, so that's what we indicated a while ago, about 5.4. Well, anyway, that's just kind of the red blood cell count. And again, you don't need to really worry about that part right there. Hematocrit, average 47 for males, average 42, and I gave you that for females, which we'll talk about that also a little bit later. Hematocrit, that's a good thing to know. Any of you know that you've ever had a hematocrit done? Yeah, you've had it done. You probably don't remember though. They said it's okay or not okay, right?
Yeah, well, I was anemic when I was pregnant.
You were anemic, so your hematocrit was low, right? Yeah, your hematocrit. So you fell down below 42, or you wouldn't have. If you had been 42, you'd have been okay. But if it drops on down, then if you were anemic, you're probably tired all the time, right?
I was really tired, yeah.
Really tired, just kind of like that, yeah. Yeah, anemia. The key characteristic of anemia, everybody, is being tired. Just being, I don't. You're ready, hey, let's go out and do something. Let's go out and I don't feel like it. That kind of stuff, okay? All right, so there's that. Functions of blood. Well, this is also kind of common-sensey, everybody. The functions of blood. All right, transport, regulation, and protection. And this is kind of what it goes around. In other words, look at transportation. Our blood transports oxygen. It what transports oxygen? What transports oxygen in the blood? Come on, think. Starts with an H. Hemoglobin. Hemoglobin transports oxygen. The hemoglobin. Hemoglobin count's got to be on up there pretty good. Hemoglobin count transports oxygen. Transport of carbon dioxide. Our blood transports CO2, and our lungs, it's very important to keep your lungs healthy. Very, very important. I mean, that's most miserable. Seeing someone who has COPD can't breathe like that. That's the thing. All right, so transport of CO2. All right, transport of nutrients. Okay, what are the nutrients? The end products of carbohydrate digestion, end products of protein digestion, transport nutrients. All right, transportation. Transport of waste. Okay, our blood transports non-protein nitrogen waste products from cells to the liver, where the liver converts most of that stuff to urea, and we get rid of it in urine. So that's transport. So this is just common. There's nothing hard here. Nothing hard about this at all. It's just kind of going through and seeing some things that happen. Transport of hormones. In other words, the hormones are called the ductless glands, right? The hormones are the ductless glands, and so the hormones empty their secretions into the blood, and the blood carries these things to areas of the body, to the target areas. Okay, all right, so there's that. Then transport of enzymes. Obviously, the enzymes are some are transported by the blood, which that's just kind of gives you some transport ideas. No big issue there. Most of that's common sense. All of you knew blood transported oxygen. You knew blood transported carbon dioxide. From having 2401 to the ductless glands, you know the hormones are dumped into the blood. They go by way of the blood to the organs, to different areas, to target areas. You haven't thought about the waste. Now, when you think about waste, think of primarily of non-protein nitrogen, NPN. The non-protein nitrogen waste. That's the main waste stuff. And then, of course, enzymes, no big issue. Don't worry about that one. But that's pretty common sense. Regulation activity. Regulation of pH through buffers and amino acids through buffers. You know, there's the carbonate buffers, the phosphate buffers. Regulation of pH, that plays a role. There's a role there. All right, regulation of body temperature, water content. That's why we sweat. Regulate body content. The blood does that, which is it's a heat absorber and a coolant. You know, the blood. So you know you can kind of figure out that, no big deal. Protection. Okay, and this is one of the key things right here, though. Protection. The protection activities of the blood. Protection will be prevent of fluid loss through the clotting. Position of blood, formed elements make up about 45%. Plasma makes up about 55%. And then we're going to say one word on this, then we'll go. There's a deal right there, y'all. Right there is a deal. That just kind of shows you plasma about 55, red blood cells about 45%. The Buffy coat, which I've never seen that, composed of white blood cells and platelets right in there. Okay, and so that just kind of gives you an idea. And I think we'll let me just put the next slide up there, and then we'll get ready to haul it on out of here. Let's get it right here. All right, formed elements, and we're going to talk about those. We'll start with formed elements next time. Now, the only thing that's really hard with this stuff right now, if you like to use the word hard and easy, one thing that you need to be sure and bring that printout sheet on blood cell formation in us. You'll see it, blood cell, or the pluripotent stem cell. You have that with you? All right, be sure and bring that. That'll take a little bit of going over, the pluripotent, that deal. And the only other thing that will give you a little bit of a problem is the details of blood clotting. Blood clotting will give you a little bit, especially the coagulation. That will give you a little bit of, you got to think about that. Blood clotting, the intrinsic, extrinsic mechanisms. You have to think about that pretty good. But other than that, this blood's not going to be too bad. It really shouldn't be. Okay? All right, it is about, that clock's a little slow. It is about time to